everyone, my name is Lex Kamitan and today we are going to talk about chi-square test for association. Now this is a two-part video. For the first part, we will define what it is, talk about its common uses, its data requirements, its hypothesis, and its test statistics. For part 2, we will use SPSS to compute for the chi-square test for association. Now, the chi-square test for independence, also known as Pearson's chi-square test or the chi-square test of association, is used to discover if there is a relationship between two categorical variables. For example, you want to find out whether people who identify themselves as DDS is likely to fact check. Now, the chi-square test of independence is commonly used to test statistical independence or association between two or more categorical variables. The chi-square test of independence can only compare categorical variables. It cannot make comparisons between continuous variables or between categorical and continuous variables. Additionally, the chi-square test of independence only assesses association between variables and cannot provide any inferences about causation. So, when you choose to analyze your data using a chi-square test for independence, you need to make sure that the data you want to analyze passes two assumptions. You need to do this because it is only appropriate to use chi-square test for independence if your data passes these two assumptions. If it does not, you cannot use chi-square test for independence. Now, these two assumptions are, first, your two variables should be measured at an ordinal or nominal level. That is, they should be categorical. You can learn more about ordinal and nominal variables in the video entitled Easy Peasy Research Methods. The second assumption is that your two variables should consist of two or more categorical independent groups. Example independent variables that meet this criterion include sex, which has two groups. You have males and females. You also have ethnic groups in the Philippines, which has 8 independent groups. You have Tagalog, Cebuano, Ilocano, Bicolano, Kapampangan, Maranao, Maguindanao, and Tausug. You can also use physical activity, which has 4 groups, which includes sedentary, low, moderate, and high, and so forth. Now, aside from the aforementioned or the previously mentioned assumptions, your data must meet the following requirements too. First, as mentioned earlier, you should have two categorical variables. And then you should have two or more categories or groups for each variable. There should also be independence of observation, which means that there is no relationship between the subjects in each group. Also, the categorical variables are not paired in any way. This means that measurements that has pre-test and post-test observations may not be used for computing chi-square test of independence. The last data requirement is that there should be relatively large sample size. Expected frequencies for each cell are at least 1, and expected frequencies should be at least 5 for the majority, that is 80% of the cells. The null hypothesis, labeled as HO, and alternative hypothesis, labeled as H1 of the chi-square test of independence can be expressed in two but equivalent ways. First, you can express your null hypothesis as variable 1 is independent of variable 2. For the alternate hypothesis, you can use variable 1 is not independent of variable 2. Or alternatively, you can use HO or null hypothesis as variable 1 is not associated with variable 2. Or with the alternate hypothesis of variable 1 is associated with variable 2. So, the calculation of the chi-square statistic is quite straightforward and intuitive. Here, you see the test formula for the chi-square test, where O is the observed frequency, which is the observed counts in the cell, and E is the expected frequency if no relationship existed between the variables. As depicted in the formula, the chi-square's statistic is based on the difference between what is actually observed in the data and what would be expected if there was truly no relationship between the variables. To reject the null hypothesis and conclude that the variables are not independent of each other and that there is a statistical relationship between the categorical variables, the p-value should be less than 0.05. Now, there are a number of important considerations when using the chi-square statistic to evaluate a cross tabulation. Now, because of how the chi-square value is calculated, it is extremely sensitive to sample size. When sample size is too large, that is about 500, almost any small differences will appear statistically significant. It is also sensitive to to the distribution within the cells. The SPSS gives a warning message if cells have fewer than 5 cases. This can be addressed by always using categorical variables with limited number of categories. For example, by combining categories if necessary to produce a smaller table. Now that we are done with the definition, common uses, data requirements, hypothesis, and test statistics of chi-square test for independence or association, let's now head on over to SPSS to try to compute this. Let's say you want to find out if relationship status is associated with having a date on Valentine's Day. So what you did is to survey 94 of your classmates or schoolmates to find this out. So you have a null hypothesis that says um, relationship status is not associated with um, having a date on Valentine's Day, and an alternate uh, hypothesis that says relationship status is associated with having a date on Valentine's Day. So you want to run a chi-square test to find this out. Remember that that chi-square test of independence is integrated within the cross tabs feature of SPSS. So all you have to do is to select analyze, go to descriptives, and then cross tabs. All right, make sure that at least one of your variable is inside the row section and your other variable is in your column section. Go to statistics and make sure that you have chi-square selected among the many inferential statistics available under the cross tab section. Go to cells and make sure that you have selected observed under the counts section. Make sure not to select expected, but rather observed under the counts section. Click on continue and click on OK. Immediately, you'll be forwarded to the output view of your statistics or SPSS. Now you'll see three tables here, and the most important of which is the chi-square test table. The first entry under this is Pearson chi-square. This is what we are interested in. As you can see, the value is 0.266, and the minimum expected count for this statistic should be 6.06 as indicated below. And because of this, the p-value is 0.606, which is higher than 0.05. And because of this, we have to accept the null hypothesis and conclude that uh, one's relationship status is not associated with having a date on Valentine's Day. That's all for our demonstration in the use of SPSS to run a chi-square test of independence. Thank you for watching.